We propose a system to optimize the cost and plan for the contingencies that may arise in virtual power plants. A virtual power plant is an aggregation of power generation units such as solar farms, wind farms, conventional generators, and storage systems. The units remain independent but are dispatched through a centralized control system. Using a virtual power plant imposes many benefits. One of the major losses in electric power systems is the transmission loss, which accounts to nearly 10% of the generation power. This can be drastically reduced by virtual power plants as the sources of generation are not in localized places. Furthermore, the lowering of cost in generation and voltage stability can be acquired through virtual power plants. Also, there are far lesser environmental hazards that occur due to virtual power plants. However, virtual power plants are already existing solutions. So what do they lack? Virtual power plants use both renewable energy and conventional generation in order to supply the loads. However, as you can see in the diagram shown, a solar irradiance of day 1 is smooth, whereas in day 2 it highly fluctuates. In such a situation, when the renewable energy fails, the conventional generators kick in. This causes system instability due to the fluctuations that are caused in the generator operation. Furthermore, the system does not account for contingencies that may arise, such as power outages or drastic drop in renewable resources throughout the day. These accumulate and leads to a huge cost that will be incurred to the energy company. So in our solution, we propose a system where we consider a virtual power plant employing renewable resources alone. A major drawback in renewable resources is its unpredictability. Therefore, by using a time series prediction method to forecast the power output from the renewable resources, we bring about a method to know ahead of time how much power will be generated and hence be able to dispatch the loads and schedule them in an efficient manner to the market. By using this prediction, we can also account for contingencies that may arise and schedule as necessary to reduce any problematic situations that may arise. These predictions and optimizations lead us to a more economical way of dispatching the load to the market. In order to start our work, we have acquired data from University of Peradeniya, University of Jaffna and Hambantota for solar farms, and we have acquired wind plant data from Puttalam power plant. Using this, we have built a time series prediction algorithm which can predict the wind and solar power outputs up to 98% accuracy 5 minutes ahead of time. So how is this going to be any better for the virtual power plant? Unlike in the existing virtual power plants, we are able to predict the power output ahead of time. This allows the controller to schedule the power dispatches to the load ahead of time and make sure that there are not any instabilities occurring. This will prevent load and generation imbalances and also prevent system failures occurring due to such problems. By running a day ahead prediction and classifying the type of the day that we will see ahead, we are able to plan for the risk factors that can come into play. And therefore, we can drastically cut down on unexpected and massive costs that will be incurred to the energy companies. In addition to the cost reduction by this, the energy storage and grid usage is run through an optimization algorithm too. This will make sure that the cost is met at a minimum point. The day ahead prediction will further reduce switching stresses on the system, which will hugely impact the maintenance cost and make the system much more viable and economical. Therefore, our solution leads to a much cost-reduced virtual power plant. It also ensures system stability in the power system and also accounts for the preventive measures to ensure that our system is viable. A business model can be built where we have an efficient system for energy companies who wish to capitalize on cost reduction and system stability. Thank you.